And sometimes they don't just have to be linear. They could be a quadratic and a straight line, and it could be... Let me write down. There's actually 3 situations when we have simultaneous equations. Does anyone know what the 3 different types of situations can be with 2 straight lines? Straight line. What can in a straight line? Yeah. So we've got the obvious, where we might have a straight line going like so, and another straight line going like so, and so they intersect how many times? Once. So what we call this is a single unique solution. And that's where we talk about, we will look at our skills of substitution and elimination to solve, and we'll have like a 2-second reminder about that. But there's another situation that can happen when we have 2 straight lines. What is that? Yes, Costi? They never intersect. In other words, aka they are parallel. Now, how can we suss if they're parallel? Just from looking at the equations. What do we know? Looking at the equations. Okay, so they've got the same slope, which means, oh, by the way, this would be no solution. So we could have, for example, y equals 5x plus 3. Okay? And another line that would be parallel to that, can someone give me another line? 5x plus 7 take 7, whatever. Okay, what about this line? Is that parallel? Yep. How come? Yep. Divided by 2. Boom, boom. Okay. What about this line? Y equals 10x. And we're all looking at, we're parallel to the top one. Is that parallel? No. Aha. So what we're talking about, so this one, yes. Parallel, no. Okay. And Charlotte? Yes? Charlotte said no. Because she said they're the same. What do you mean by they're the same? Yep. If we divide this all through thing, it's basically, it's a multiple of that one. Okay? So that's got a special name. That's when we have, let's say, a line like so. And then we have one that's sitting right on top of it, and it might extend out, but whatever, but it's right on top. It's got a special name. Anyone know? Starts with a C. Wow. Okay. So this is what we call, they would be coincidental or coincident lines. Okay, and in this case what we say is there are infinitely many solutions. And that sort of makes sense because they're lying one on top of the other. So this is a point, this is a point, this is a point, and so on, right? Infinitely many. And as we said, that would be when we've got one line being a multiple of another line. We groovy with that? And of course, when we've got this one in the form y equals mx plus c, you could also handle it being in general form, couldn't you? So if we've got, I don't know, 5x plus 3y equals 7, what would be another line that's parallel? 5x plus 3y equals, yeah, right? So they're parallel. And of course, what couldn't happen would be minus 5x take 3y equals minus 10. That's a no-go. No multiples. So we've seen that little bit of memories, like the corners of my mind. Hi, Spence. How was music? Good? Who are we missing? Jackson and Ishan and Dion. Well, Dion, I don't know if you're playing cricket. The other two, I hope you're doing a good job. Don't come back if you lose. This is a little bit more about Do you understand the whole parallel, one solution, two solutions, infinitely many solutions? All right? So consider we've got our two equations there. We're writing. You could have an example. Spence, why haven't you got your stuff out yet, my friend? So we've got two equations. Find the values of m and k, rot roll, two unknowns, when we've got no solution. And as soon as we see that, that's just code for parallel. And therefore we're going, I know what I have to do when they're parallel. That would be, they have the same slope. Do I know what the slopes are? Do you? Can we work out what the slopes are pretty quickly? Yep, just by rearranging. So we're going to have m take 2x plus y equals 2. You're going to rearrange that to get y by itself and tell me what the slope is. And you're also going to have mx plus 2y equals k. You will rearrange that, go forth, and tell me what the slope is. I'll give you 30 seconds. We don't wait any longer for Finn. Okay, this is going to go over the other side. Minus m take 2x plus 2, if anybody disagrees with what I've said. That goes over. Okay, I could have left out that line and gone straight to 2 take m x plus 2. And I would like to think that I haven't bamboozled anybody here. What have I done? Yep, I've just times through by the negative here. So negative m, negative and a negative is a positive, and so that's a nicer way to write it, rather than minus m plus 2. That looks goopy. That looks sweet. Would you agree? If some of you left it like this, no big deal. It's just we're trying to tidy stuff up a little bit now. Everyone happy? All right, and over here, keep the 2y, the m goes on the other side, mx goes on the other side, becomes negative, and we've still got our plus k. I'm a lazy individual, so I don't need to do the next bit, because at this point I can now say, haha, the slope here, and I've got to say it's really annoyed me that they've used m as one of the unknowns, because I really want to go m equals, m for slope. Ugh, swines. So I'll just make up my own little slope equals 2 take m, and over here the slope is negative m over 2. So back to the question that they were asking us, when is it going to, ooh, yowza, when is it going to have no solution? When it's parallel. So what does that mean about the slopes when they are the same? And I'd like to think that we are then going, well, that's when they're equal. So for part A, they will have no solution when 2 take m equals minus m on 2. We down with that? Nice linear thing to solve. Tell me what m is, people. So you times 3 by 2, 4 take 2m equals minus m. Get rid of the take 2m, plus minus 1 plus 2 gives me just 1. And you think, fantastic, done and dusted. Would you agree? Yeah, no, you're not. That is actually not finished for part A. Because, anyone know why? Go back to what we were talking about over here. Now, we could have said, yeah, look, these are all the same slope, and even if I had y, didn't change colour, 5x, plus 3, that would not be parallel. Why? It's the same one, or multiple, it's going over the same thing. So when we come back to this, love the face, you're frowning at me, right? When we come back to this and I was to put 4 back into my two equations, back in here, I will end up with this one becomes y equals 2 take 4 minus 2. We're all happy? So we get minus 2x plus 2. And if I put it back into this equation, so now I do have to rearrange it, swines, right, I would end up with y equals minus 4 divided by 2 is minus 2x. 4 divided by 2 is 2. That wouldn't be good. So I don't know. Oh, I'm not even replacing it. I ruined the surprise. I've got this. So what are we saying this value can't be? Yeah, that cannot be 2. Otherwise we've got the same equation and we've got infinitely many solutions, right? So we have to come back and refine this. For there to be parallel lines, m has to equal 4 and k cannot equal 4. Right? That whole thing can't be 2, which means 4 divided, I know what you meant, 4 divided by 2 can't be. Does that make sense? Happy? That is the answer, the whole thing. If you just left it as m is 4, no shebang-a-bang. You haven't actually completed it. Okay? And if we go back up and we look and we see, ooh, infinitely many solutions. Aha! Well, infinitely many solutions will be the same, m is 4, but k has to equal 4. And last but not least, when will there be a unique solution? When it's not parallel, so basically when m is not equal to 4. Any restrictions on k? Now, so k could be anything. How do we write k could be anything in mathematics? Sorry, those people at the back. Have you ever seen this? Oh, okay, it does occur. So this is a Greek letter, epsilon, and it just means is contained in the set, element of, and fancy pants are, that's real numbers. So you'll find as we're getting higher up with the mathematics, some of these little notations will come out and you're going to go, oh, I know what that means. Yeah? So I'd like you to start using that sort of thing as well. So what do we take away? If they're parallel, same slope, make them equal each other. They're going to be, you have to avoid the coincidental one where one is a multiple of the other. You okay with that? And of course, you might also be asked how to solve simultaneously. Can you actually find the unique solution? So if we said m is 10 and k is whatever, could you find the simultaneous solution? Do we need a quick recap on that or not? So try it quickly. And again, if you just have this on one page, you can go back and have a look if it crops up. Okay, so to find the unique solution, we've got two methods. We've got the substitution method, we've got the elimination method, and it's all about how the information is presented. Substitution, I think, will work every single time, but sometimes it's a little bit more effort than is necessary. Alright, so with this one, it's clearly set up for what method? Sub. Because I've got y equals, and of course, instead of having y equals, it could be x equals. You could do the same thing. But what we're going to do is wherever y appears here, sun, we're going to replace it with this. Now, you've got work that you could carry on if you think you don't know. If you know this, you carry on, but it's not typing. Otherwise, I will take your laptop. That's now on the video. All right, so we're going to sub it in. It becomes 3x plus, and instead of 4y, 4 times y, we're going to say 4 times, what do we say y is? 2x. Take 9. Equals minus 14. I put minus 14. Happy days? And all of a sudden, you might be thinking, she's nuts. Because, you might go, that wasn't of a sudden. I knew that all from the beginning. It looks uglier, except Why is it so nice? Why does it work? How many unknowns are there? I would say there's one unknown. It occurs twice. Here we had x and y, and there would be infinitely many solutions if you tried to solve them individually. Here I've just got x's. I can now solve this beautifully. So expand, we get 8x. Take 36 equals minus 14. What does that become? 11x equals 22. Oh, very nice. It's one that I prepared earlier. And so x equals 2. Where did I lose you? This is the hardest step, Finn. That is the hardest bit. So wherever y appears here, I'm going to replace it with the thing that y equaled. Right? So 3x plus 4 times y, but we're saying this is y. You happy with that? I'll come and see you separately. I'll come see you in a tick. It's all right? Yep. And then, shh, hello. Not done. Evan, what would we do next? I've got my x value. I'm not finished. Sub it in. Sub it in where? Sub it in where? Right, the one we want y, so we're going to sub it in here. You could put it in here, but you're doing too much work. So we're going to put it in here. 2 times 2. I'm writing that. So it's 4 take 9, and we get y equals -5. In my day, to check that I'm right, I didn't need a graphics calculator. All I would do is sub these two values, x equals 2, y equals -5. I'd sub it into the other equation that I hadn't used, and if it equaled -14, gold, Jerry, gold. You guys have wonderful graphics calculators that you could be lazy as and check. So who can tell us how do we use our graphics calculators to check a simultaneous solution? Who's never used their graphics calculators to check? Couple? Good. I'd just like to know I'm not teaching you stuff you already know. So here we go. So Finn, playing along, got your calculator up. We want to go to, take it away, Dash. I love it. Enter. Wouldn't be Polly. I don't think he's reading the screen. Yes, he's not reading the screen. It says simultaneous. That's one of the reasons I love these calculators. So F1, number of unknowns. You might have forgotten, sorry. 2 unknowns, and it tells you nicely in what form it wants it. So you can see up here it wants the x first, then the y, and then the constant on the other side. And I have to say that's one of the reasons in general form I always put it like this. Anyway, so we come back. The first one is 3, 4, -14. So we go up here, I'm going to press 3, enter. 4, enter. -14, enter. I sigh a little bit because when I look at my other one here, I go, oh, that was a sigh. What? Why am I sighing? I have to have x's and y's on one side, but you know what? The 2 just comes over. Yeah. So I'm putting in -2. It was a 1y, and what was the other one? Equals -9. Now, if you did that all the other way, because you went the other side, you would have had 2 -19. You'll get the same answer. You can either press solve or be bold and press enter, and lo and behold, we get, huzzah, the same answers. It is really special. Who can come up with a different way using the calculator to find the solution for this? Yeah, you could graph it. But again, the graph function is a little bit painful because you have to have it all in y equals. So you'd have to rearrange. And you then have to sort out the scale. So equation, pretty good. Is there another way? No, that's it. All right. Okay. So the next one, we could rearrange and substitute, get x by itself, substitute it in here, or get y by itself. But why would that be a little bit painful? They'd have fractions. And as much as I love fractions, I want to try and avoid them today in this situation. So the idea of elimination, what does eliminate mean? To get rid of. So I want to get rid of either the x's or the y's. And in order to do that, we have to have the same, starts with a C, coefficient. Who said that? Well done. All right. Doesn't matter if you choose the x's or the y's. I tend to choose the smaller one and normally the one that comes first. So what's the number 3 and 2 both go into? 6. So that means I have to times that by 2. Times that by 3. Yep. Okay. Where do most people make an error here? I know I do. You have to times every single one by that 2. You have to times every single term by that 3. Sometimes we forget about that little last one. Keng, I need to see that you are listening, please. So we end up with 6x plus 10y equals minus 14. And play along. Hopefully you don't need me to say. Yeah. And once you get to this point, you have to make a decision. You're going to add the equations or subtract them to make sure that the x's eliminate. Clearly, it's going to be a subtract. I like to put it there nice and big so I can see. And then 6x takes 6x. Yay, huzzah, we've got no x's. That's what we wanted all along. 10 take 9 becomes plus. So we get 19. Minus 14 take 33. Again, you've got to plus. Minus 14 plus 33 gives you 19. Therefore, y is 1. How do we get the x value? Sub. Which one are you going to sub into? Doesn't matter. Pick the first one, get your y value. Again, in my day, no graphics calculators, sometimes no calculator at all. We used to just doodle in the sand. We would substitute in both, and if we got different answers for the y value, whatever, then we're stuffed. We got something wrong, we have to go back and fix it. So, you know, you can check, so you can find x, and you can use your calculator to check that you're right. All right? What I would like you to do now is go back. I think this is all 2H. Have a go at some of those. Oops, where'd it go? So 2H, the ones that have been suggested. If you haven't done the 2F, we asked you to do 7 and 8. I'll put the video up if you want to. And then I will disturb you in 15 minutes to talk about notation. But it should be revision. In question 3. We've got 2 lines. This point here is where they intersect. It's lying on both of them. Shh. Shh. This is your x. This is your y. What must you do? Sub. That's right. We've got y equals mx plus c. All of this is basically saying that 515 lies on this line. It lies on it. Yes? This is your x, this is your y, so we just slap it in. 15 equals 5 times m plus 6, and we should now be able to solve. Yeah? Why shake your head, Cost? Why? So again, this comes back to, sadly, literacy and reading the question, not maths. It's where we can all agree we're a little bit frustrated. Okay? It's at the point, means it lies on the line, sub it. You all right? Looking depressed. Okay, hello. Just with question 7, everybody. I'll be honest with the chaps up the back. They asked about question 7 like 10 minutes ago. It's so good. Anyway, hello. Can we all listen? And I read the question. I'm going straight to infinitely many solutions. I'm going, well, what does it mean, infinitely many? It means that the slopes have to be multiples of each other, blah, blah, blah. And I was just trying to pick numbers to put in there. And I went, and it wasn't working. And believe it or not, that happens quite often. And I like that. Because I've been doing this for so long, you sort of have the same questions over again and they become routine. I like it when there's a different type sort of question. I went, well, that's not working. What else can I do? It's all about slopes. So what do you think would be a sensible thing to do? Find the? Yes. So could I ask you, for each one of these equations, can you rearrange it to find the slope? So do that as your first hint. Find the slopes. I can now suss when I will actually have no solution, because I can go back here and I haven't solved this one yet, but I can at least do this one, and I know that there will be no solution when they equal each other. Would you agree? This now becomes a little algebra, and I warn you, when you try and make these equal to each other and you've got to cross multiply, you will end up with a quadratic equation. Okay? Try and refresh your memories of how to factorize, or use your graphics calculator, equation polynomial. I'll circulate if you need assistance. Costa, are you doing 7? Oh dear, okay. So, I've made the slopes equal, which meant we had to cross multiply. Everyone happy with the cross multiplying? If you don't sure how I got it, speak now, forever hold your peace. M times minus m. As soon as I see the m squared, it's a quadratic, so let's get everything on one side. It's at this point. Can you factorize? The steps that you go through to factorize, is there a common factor? No. Does it look like difference of 2 squares? No. Are there two numbers that times together give you minus 15, but add up to be 2, right? And hopefully we can all see that the two numbers that have a difference of 2 that times together give me 15 are 5 times 3. But when I times them together, Jeremy, one has to be positive and one has to be negative, because that's how I get the negative there. But when I add them together, I want positive 2. So which one is positive and which one is negative? Has to be positive 5 and negative 3. Plus times a minus gives me the minus 15. 5m, take 3m, gives you positive 2. If you had it round the other way, minus 5m plus 3m would give you minus 2. That's no good. We finish off m equals minus 5, m equals 3. Just pause for a moment, and could everybody just watch this for 2 seconds? I'll be honest, 30 seconds. To solve a quadratic, I'd like to think we now all know that we can go down here to equation, polynomial, degree 2, you put your doodads in. Yes? Has anyone solved it in run mode? Please watch. Do I remember? Math? No. Okay, option. Let's do this together. Calc. And we've got solve n. So we'll do that again. Option, calc, solve n. And you can now type in your equation. So it's x squared, this is my x here, x squared plus 2x, take 15. Anyone know where their actual equal sign is on their calculator? Yep, so it actually comes up as an equal, so shift dot equals 0. Yes. I close my brackets, I press enter, and don't be alarmed because you're going to see red on your screen. Exit. It's just saying more than one answer exists, and minus 5 and 3. Bang. They're so worth the money. Yep. Exit. Option. Calc. Solve n. And then you type in, that's your x here, plus 2x minus 15, the equals, see it's in yellow above your decimal point. Don't click alpha, no. This is your x here, see x theta t? That's your x. Shift equals 0, close your brackets, enter, and don't be alarmed, bang. Back to our question, we've got these two values for m is minus 5 and m is 3. And you go, big whoop, what should we do now? Sub them back into the equations and see what we end up with. Now, when I pop it back in here, you pop in minus 5, see what happens. What do those equations look like? Pop in 3. Again, observe the equations. 1 will be the situation where you get no solution, and 1 will be a situation where you get
infinite solution.
You got a little bit shy when I put the microphone in front. Anyway, there you go.